Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. It gives me great pleasure to welcome Dr. Elizabeth Rauscher, a world-renowned physicist, researcher, and presenter. You want to stand by and don't move as I tell you a little bit about her. She has spent her life making the world a better place, disseminating new knowledge and information. She has a Ph.D. and MS in astrophysics, nuclear physics, and engineering. She is the founder of the International Tesla Society. She has served on a Congressional OTA Advisory Committee. She is the author of 275 scientific papers and 6 books. She holds more than 3 U.S. patents and 1 European patent. She's the co-inventor with W.L. Van Bijs of non-superconducting magnetic detector, external magnetic pacemaker, and pulsed magnetic pain control system. Both have been issued patents in the U.S. and Europe. Her main field of research has been nuclear and atomic physics, astrophysics and cosmological models, plasma physics, biomedical engineering and geophysics, monitoring and data analysis. She's received tons of awards and grants, and she is listed in 11 Who's Who, including Marquis Who is Who, and Men and Women in Science and Technology. She's been a consultant to the Navy, to NASA, to many companies. She is a very brave lady. She's gone through a lot in her life to bring forth what she's bringing forth. Ladies and gentlemen, welcome Dr. Elizabeth Rauscher from her home.
Thank you very much. I really appreciate your program and I appreciate your listeners, and I am very excited to talk to you today.
Well, I'm intimidated to talk to you, so I've had to have a lot of water before I get here to keep myself fluid and relaxed.
Yes, I was thinking I'm kind of short. I'm not exactly an intimidating stature, but I don't know. I think people may be intimidated by knowledge and information, but actually the truth shall set you free, as it says in the Bible. I think the path to freedom really is gaining and disseminating knowledge and making the world a better place. And that's all life on the planet and probably throughout the universe.
Your work at SRI, Stanford Research Institute, is particularly interesting to me. Of all the things that you've done many interesting things in the area of radio physics laboratory. And that was a position you held from 1974 to 1978. What did you do there?
It's interesting. The radio physics lab doesn't sound like a place that you would study consciousness. But throughout my life, I've been interested in the nature of consciousness. I study physics because it's basic and it's easier. Consciousness is really a complex problem. It isn't even well defined. But I was interested in psychic phenomena, but extremely skeptical. So I approach each thing I study as an open-minded skeptic. I heard about the program down at SRI that Hal Puthoff and Russell Targ had started, working with wonderful psychics Pat Price and Ingo Swann and others. So I called him up one day. So Russell asked me what's on his desk, and I said, I see a ball and socket joint. It turned out it was a crystal ball in a wooden cup. So I got invited to come down, and so the next day I'm meditating and the phone rings and I said, oh darn, it's Russell canceling. And it was. He was going to say, we're too busy. And I said, well, you guys have to go to lunch. He said, okay, come down. So I went to lunch with Hal and Russell and Ingo and ended up doing a multi-year contract to study consciousness and to see how it fits in with the main body of physics. Because one of the objections to psi, or non-locality of consciousness, is it's denied by the main body of physics. But actually, I have developed a whole set of theoretical models, multidimensional models, that have published in physics journals and physics books that show the compatibility of psychic phenomena with the main body of physics.
Really?
And it might even be that physics implies a non-locality that does relate to consciousness. Now, there's many attributes of consciousness, and really psi involves non-local interaction. That is, The experiment that was set up at SRI, really by Russell Targ and Ingo Swann, were that if you define a geographical location by having someone go pick sites, put them in envelopes, that is where the target location is and what it is, then that's undisclosed to either the recipient or anybody else involved in the experiment. Then someone randomly chooses one of those targets, goes to the site for 15 minutes, and the person in the laboratory, say Ingo or anybody else that volunteers, and when I was doing the experiment, it was either the engineer or the secretary down the hall free for lunch, because it was not a highly funded project, would attempt in the laboratory, closeted from any ordinary connections, to perceive where the outbound person was. They have met, but they don't necessarily have to know each other well. I used to take them for lunch so that they get acquainted. The first experiment I was involved with, I was on the outbound team, and the subject described in detail was Jeff Mishalov, that I was cold and mad because I forgot my sweater. Well, I didn't know it was going to be an outdoor site, and that's exactly what I thought. I was cold and I was angry, and I thought, man, this telepathy works really good. And his rest of his description was exceedingly accurate. It was the Oregon overpass, and I looked up, and the cyclone structure looked like lines against the blue sky, and that's what he described and drew. There were yellow and pink flowers on the hillside. He described those. He drew it very accurately. There was another time that I was at a target similar to that one, and I used to take a clipboard, take my outbound notes, and there was this nice old policeman with shorts on coming up to me and asking what I'm doing. And I said, well, there's a remote viewer back at SRI trying to perceive what I'm experiencing for 15 minutes at this site, because I was rubbing the cyclone fence and stuff with a clipboard, so it looked a little odd. And he phoned his other buddy down the police car, this is a 50-50, and left. And I thought, well, maybe he'll get picked up in the remote viewing. He didn't. But it turned out a 50-50 means crazy but harmless. Found that out later.
Oh my God.
So there's very interesting experiences you have. And then what happens is the transcript, which is tape recorded of the subject, and their drawings are locked in a safe, and the targets are locked in a safe and kept away from anybody that's directly involved in the experiment. And then we used human judges and then computer judging later. A human judge judges the matching of the targets to the transcript for about 6 to 8 different remote viewings that are in a particular experiment. Well, this was done over and over, hundreds and hundreds of times. I've done about 80 of them, and the correspondence is highly statistical against chance. Millions and millions to one against that many matchings. So I found out that psi is real. I spent 3 kind of sleepless nights adjusting to that, because at the time I was at the Lawrence Berkeley National Laboratory, and I didn't quite think it was appropriate for me to go to the director of the lab and say, hey man, psi is real. Didn't think that would go over too well. But later some articles came out in the National Enquirer, and was I busy trying to cover the tracks. Man, I tell you. Well, actually, some of it was true and some of it wasn't. Comparing things like the National Enquirer to standard news and articles on me and people I knew, I would say about half of everything you read in the newspaper is wrong. Half is probably fairly accurate, and it doesn't matter whether it's a weekly rag or a so-called bona fide newspaper. So don't believe what you read all the time.
What happened to you when you realized psi is real? And when you say psi, explain what you mean to the audience. What is psi to you?
Well, in the remote viewing, the idea was to give it a different label and not necessarily try to define it as telepathy or mind-to-mind or clairvoyance, which is clear seeing, or clairaudience, which are the old words for psi, or precognition, this being able to tell about a future event before it's happened and then notice it happening. So one of the things, I think Russell came up with the term, or maybe Ingo, remote viewing. I call it remote perception because sometimes other sensations besides seeing the target occur, but it's predominantly seeing the target. And in some cases, if you can't go inside the building or whatever it is that's the target, the psychic percipient can go in and sometimes realizes that you can't go in, but they can go in and see what's inside, see things that you didn't see at the target. It's got very many facets. Russell has a 4-choice trainer. I think he has an app on it, but what it is you're trying to choose the next color that's going to come up on 4 choices. Well, when I was staying at his house at the time when I first started working at SRI, I got perfect chance. After I realized psi existed, at least to some degree, I got way above chance. So belief is a big thing. It is in anything in life, is to open your mind to possibilities. I think it's very important to be open to possibilities, but I also think skepticism is very important. And I use the scientific method to screen against something that is either not relevant to your life or may be useless or may be untrue. Now, I put the categories this way. There's accepted truth, and I'll mean by that practical knowledge, not ultimate truth, but practical knowledge. There's a lot of accepted untruth. There's a lot of rejected truth, and there's a lot of rejected untruth. So you have to really sort through things. It isn't that simple. It's actually a very difficult process and takes a lot of endeavor. And even then, there's always people trying to fool you. But one of the keys to the whole thing about psychic phenomena and that aspect of consciousness is that it tells us we have to tell the truth because telepathy works. I'll give an example. After I decided this was real, I had done enough experiments at SRI, I set up the Berkeley Research Group and replicated the experiments with a group of researchers I put together at Lawrence Berkeley called the Fundamental Fysiks Group. David Kaiser wrote a book, How the Hippies Save Physics, which was on my group that I started and chaired for 3.5 years. One of the tenets of that work was to replicate the SRI work, which we did, and publish it. The other thing was to look at John Clauser's non-locality experiment in quantum mechanics. Now, quantum entanglement, people are hearing about that more in the popular press. But what it is that if a decay of an atom occurs where 2 photons are emitted approximately at the same time, they go out from each other at the speed of light because they're photons, they're quantum of light. They have spin 1. So if I measure one non-local to the other and it spin up, I know the other one spin down. Well, that would have to be transmitted apparently at a superluminal signal. And physicists have written a whole bunch of papers on this, debating what the interpretation really is. But non-locality was sort of neglected, and now it came into the fore through the Fundamental Fysiks Group, according to Kaiser. It's a book for the general public, and he's an MIT history professor, history of science professor. Quantum non-locality may not explain psi. Some figured it might, but actually it had to be a larger macroscopic view, that I think. And so I developed a complex 8-space geometry that made it look like you could mentally make San Francisco, where a remote viewer might be, and New York look contiguous in a higher dimensional space. So if I go up in the air in a helicopter over a mountain and there's a road around the mountain, 2 cars are driving towards each other, but they can't see each other. From the higher dimensional view, you'll see that they are going to meet and pass, so you can predict that. That's like a precognitive event by accessing a higher dimensional space. So I believe one of the fundamental attributes of consciousness is non-locality, and it requires a hyperdimensional geometry to describe it. Part of the hyperdimensional geometries I looked at actually are considered as part of the standard model of physics. And it was after I'd given a lecture very early on when I decided the remote viewing was true. A student followed me out of the lecture, and I was Xeroxing a physical review article in the library at the Lawrence Berkeley National Laboratory. And he started pounding on the Xerox and saying, "This can't be true, it's denied by the main body of physics." So he's ranting and raving, and I'm thinking, man, I don't want him to bust the Xerox before I get this article copied. So I thought maybe I better try to work out a theory to at least keep someone like him quiet and from pounding on poor copy machines. And so that kind of got me thinking. I had sort of thought about it even before I went to SRI about how you would accommodate the non-locality of consciousness in the main body of physics.
I just want to clarify something. When you're talking about non-locality as well as Russell Targ and the whole remote viewing teams, part of the core of it is that your consciousness does not live in your brain. It's not from your brain. It doesn't live inside the brain.
No.
It interfaces with the brain.
That's correct.
Is that correct?
Well, you know, I started to think, what is a thought? And I remember I was about 8 or 9, and I was watching my cat try to make a decision. I think the one with my dog was more interesting. What happened was it was raining, and I was going to let the dog out to go pee. The dog saw the rain, didn't like it, but he needed to pee, and he couldn't quite cross his legs. But for about 5 minutes, he went back and forth, went out far enough to look at the rain, not get in it, trying to make up his mind. So he's got a thought. He's making a decision. Well, after 5 minutes, I decided that it was too long, and I kicked him out. But I don't know how long he would have taken to make that decision. But thoughts are real. Thoughts are things. And not only humans have thoughts. So what are thoughts? Think thoughts. And is consciousness beyond the brain? Well, I've always intuitively felt yes. Definitely that it's more the mind or our consciousness and perhaps spirit. And there was a conference in India with physicists, Buddhists, neurophysiologists, and various other scientists. The physicists and the Buddhists got along fine, and the neurophysiologists said, well, it's just a synaptic connection in a neurotransmitter. Don't think that explains love, although you might throw in a few hormones there and try to make it up. But no, I've always kind of felt that that wasn't the case by intuition. And I think by experimentation, it's clear that consciousness transcends the brain, to me.
What do you think about what just recently happened with Dr. Rupert Sheldrake? He was doing the TED Talks and doing a lecture, and the board of directors of the TED Talks just relegated him to being a pseudoscientist. They said he doesn't have real peer review work. He's been doing research for years in telepathy and consciousness. And what do you think of where science is, and obviously on some level academia is today?
Well, in my fundamental physics group, I walked in one day and said sim salabim.
What's that?
And bowed, because that's what Johnny Carson used to say. And I said, you realize this is a cult. This is dogma, that science is a very specific methodology. But it doesn't work without intuition. Now, 3 of the 40 people laughed and realized to some degree it's all a religion. And that science itself has its priesthood and its dogmatism. And it's very much into the analytic, you know, the idea of I'm going to understand a Swiss watch and I'll take a hammer and smash it and then look at the pieces. That's really what an accelerator does. But it isn't the whole picture. You can't really do science without intuition or perception or gaining a global concept. The pieces is too couched in analytical approaches. It's very valuable and very useful to have those approaches. Now, Rupert Sheldrake I met years ago, and when he came out with his first book on morphogenic fields, there was a large article in a pretty well-known journal. I forget which one it was, and it said a book for burning was the title. So I wrote a response.
Was it the New York Times?
I don't know if it's the New York Times. I can't remember now, but it was presumably a legitimate publication. I wrote a response saying, a book for non-burning, because censorship is a very dangerous, slippery slope. I mean, there's a lot of things going on in this society that I don't go along with, or belief systems that I don't go along with, but I don't go around saying they're wrong, because that's not my business. And it's not their business to judge Rupert Sheldrake. He's done his research. I don't know if he's published in peer review or not. I guess I presume he has.
Well, they're claiming he hasn't.
Let's put it this way. One of the problems is, of course, there are belief systems that do run the society. So getting something in that area of research, to get it in peer review like the IEEE in Nature, which Hal and Russell did, and in the Foundations of Physics, which I did, is very difficult. And then Dean Radin has published recently in a peer-reviewed physics journal, Physics Essays on Non-Locality of Consciousness. But I can't say whether Rupert has or not, but any censorship or burning of books, if they asked him on, I mean, even there's the politeness issue. I don't know what TED is.
I mean, TED is a platform where people share their ideas, and people, known and unknown, come on TED Talks and share their ideas. So I think it was outrageous. I'm
think
totally
censorship
upset.
is very, very dangerous. Velikovsky wrote Worlds in Collision and was had McGraw-Hill publisher going to publish Worlds in Collision. I think it was in the 50s. And the astrophysicists at Cornell said they never publish in McGraw-Hill if they let Velikovsky's book go forward. So they actually censored it and didn't allow it to be published in that publisher's agreement. He published it elsewhere. But there was a whole bunch of physicists that were lambasting Velikovsky. I mean, he had, I think, 3 Ph.D.s. I know he did a lot of work in history and archaeology. But whether what he says is true or not, he certainly has a right to say it.
Absolutely. Absolutely. Talk a little bit about what prompted you to start the International Tesla Society.
Oh, very interesting, because I'm not sure. I think sometimes the future affects the past and the past affects the future.
Well, I just have one quick question before you answer that. Are you and I in the future right now?
We're in the future to our past, relative to our past. And maybe time doesn't exist in a linear fashion
I don't
anyway.
think so.
I mean, man, I'll get to that after the Tesla Society. My sister's first husband was working for his Ph.D. in math and physics at Berkeley. So he was an ideal person for me to meet when I was 11. And he talked about all kinds of stuff like Foo Fighters, UFOs. He was a weekend warrior. I think he was in the Navy Reserve. So he talked about all kinds of cool stuff, neat jet planes. I mean, stuff. I just love rockets and planes. I was just really excited about this stuff. And he talked about some guy that drove a car 300 miles in a black box, which turned out to be Tesla. So I got interested in Tesla. And I got interested in the idea of invention, and one day I thought, well, you can't invent stuff without having stuff to invent with, so I started collecting old radio tubes and pretty much, in general, useless stuff. But between 9 and 13, I built 6 telescopes, and I built them out of assorted lenses I got from Edmund Scientific and some old map tubes that my dad had. And I started working on building a rocket, and I thought, well, I think I want to remotely set this off. I don't want to blow myself up. Now, my late husband built one, but he did blow his arm up.
Oh, my God.
It healed, but it was a pretty bad experience. So I told my mom I wanted to learn radio electronics. So she started taking me into night school after high school to radio electronics. So I learned electronics, which was useful. Then I decided I was imposing on her too much because she had to take me down at 7 and pick me up at 9 at night from a local high school. And this was all when I was about 11 or 12. And then I was going to build a oscilloscope, but I didn't even kind of know what one was for. But I built a Wilson cloud chamber. And how I got this wonderful lab was my sister got married, moved out, and left this huge dressing room, which I promptly painted the top lab bench black and started collecting stuff and making stuff and turned it into I had a full chem lab. through high school and college.
You were really inventing as a young child.
Oh, yeah, yeah. And so it's like Tesla was an inspiration to me. And then I commuted, so I drove on Tesla Avenue years later. And then I was talking to some friends, and I realized in 1983 that 1984 would be the 100th anniversary of Tesla coming to this country. So I got the idea of getting scientists to re-examine Tesla's work. I asked my Nobel Prize-winning friends what they thought of Tesla before that, and they said, well, he invented AC, went nuts, and fed pigeons. That's all they'd say. They didn't really say anything about him.
That's surprising. That's really surprising.
It's really bad. And so he was basically written out of the history books. And even the IEEE, which he published in, wouldn't acknowledge him.
Terrible.
So I had an agenda where I was going to get Tesla written back in the history books, get people to research seriously what he had been doing. That was actually, most of what he was doing was the basic of all our electronics and our electrical system, the worldwide electrical grid. DC can't be transmitted that far. At least it has to be at humongously high voltage. But he had been ignored. And then a group of people doing a film from Belgrade on Tesla came by and interviewed me. But anyway, what I did is I started writing all the people I knew that might be interested in Tesla and set up a meeting in Colorado Springs, which was the first International Tesla Society meeting. There were other people that were struggling for power within the group. I've had 3 experiences: setting up groups and running them, like the Fundamental Fysiks group, or being elected to groups and running them. And the third was starting a group like the Fundamental Fysiks group, and a couple of years later getting kicked out. Now, the reason I got kicked out is they wanted to make it more commercial and less scientific. Kind of got invited to come to a few meetings more recently. My feeling was to really, with help, got the IEEE to sponsor the conference.
Well, that's great.
And the AAAS. So they did co-sponsor the first conference. And we had a really good group of papers. We had 300 people. So I really wanted to keep it on a scientific basis. And I invited people that, were into the Tesla's life and history to speak too. So people got an idea of what Tesla was like. And there was some interesting connections. Later, I did a consulting job and ended up going to the New Yorker hotel and going to the room where Tesla died. And that was very interesting. So that sort of intertwined with everything. We got a whole bunch of exhibits of Tesla's work throughout the United States. There was a New York Times article on starting the International Tesla Society. It's still going, and it's actually got at least 300 or 400 attendees. Some of the stuff I personally feel it's speculative, let's put it that way, and that's okay. But I would like more scientific, hard-nosed work on his work, because I think it's so valuable. But I did accomplish some things, whether I got kicked out or not.
Talk about that.
There's now several programs on the History Channel that are all completely devoted to Tesla. I mean, he really was getting ignored. And then someone sent me a really interesting YouTube, and what it was is a bunch of guys rapping of Tesla Edison's fight. And it was pretty well done and pretty accurate.
Talk about that, because I think people don't know really the distinction between Edison and Tesla and what went on. And I also later would like you to share about what happened with Westinghouse you were sharing yesterday.
Oh, yeah.
I thought that was very interesting.
Okay, what happened was, when I got into the inventing idea, I definitely did not think I would be able to compete with Edison on over 1,000 inventions. For one thing, the cost of getting a patent is so expensive that I calculated it'd take billions of dollars to pay the attorneys and pay the fees. So that seemed to be an impractical goal. But J.P. Morgan, who actually, as far as I understand, lent money to the United States in, I think, 1913, started the Federal Reserve, was one of the industry giants like Rockefeller and so forth. But anyway, he was funding Edison to a huge amount. I mean, it would be like if I had Edison's lab now, I'd be getting funding of about 10 to 100 million a year. Well, that's a lot of bucks to blow on stuff, and you can hire a lot of people. I mean, he had the genius ideas. And of course, Rockefeller had purified kerosene, so everybody had kerosene lights. And that meant you had night lights. You could go out at night and not get mugged, or at least see where you're going. But some of the kerosene was not being well refined, and that's how Standard Oil started, that he refined it so that it wasn't explosive. Then, of course, Morgan came along and saw these light bulbs that Edison had and started funding that whole program. And then Tesla had worked for Edison. He was supposed to get paid $50,000 for making generators for Edison, a bonus of $50,000, which would be, I don't know, several million now. Nice pocket change. And then Edison said, that's an American joke, you don't get the money. So Tesla left and dug ditches for about a year, but got to set up his own lab and went into partnership with Westinghouse. And Westinghouse and Tesla agreed that it had to be alternating current, that electrons would move back and forth in the wire instead of having to go all the way around and come back like you would in DC, because in DC the cables would be like several inches in diameter, so that's like aught, I think, instead of maybe being 20 wire gauge, so regular wire like you have with plug in your appliances in your house. So the war of the currents occurred. There's a lot of details there, and I don't know how much you want me to go into that.
Well, whatever you think would be relevant to the audience understanding how profound it is.
Morgan said, you better squash this AC thing with Westinghouse and Tesla. So then Edison started electrocuting elephants. They tried to electrocute a convict, and it didn't work very well with AC and kind of fried the guy. It was horrible, as the reporter said. But the key was that Westinghouse and Tesla got the contract for the Chicago World's Fair? The listeners will correct that. But anyway, to light the huge International World's Fair, which they would have to present all kinds of new ideas. It actually was a way of interfacing with commerce worldwide. They didn't have the internet. It was like a huge trade show, enormous trade show. But the key was, he wanted to use Edison light bulbs. Edison wouldn't let him because it was a patent infringement, so he invented his own light bulbs. He also invented fluorescent lights, radar, and Marconi worked in Tesla's lab for 6 months and stole a radio, but that really actually is recredited to Tesla by Congress in 1943, the year
God.
He died. But anyway, the War of the Currents was very crucial, that in spite of Morgan and Edison, that the Niagara Falls project to make huge generators was given to Westinghouse and Tesla. Now, Tesla had a contract with Westinghouse that he gets something like 3 cents per kilowatt hour produced. I don't know exactly what the contract read, but Westinghouse was financially going under. So Tesla tore up the contract to help him out business-wise, but that was a mistake. I would have renegotiated the contract. That's one thing to learn from that, because he ended up living in poverty. Tesla did. But anyway, that's how the whole power grid and AC came into being. Accelerators, you know, all our electronics really is based on Tesla.
What do you think of CERN in Switzerland?
Oh, okay, that's a very interesting question. How big an accelerator do you have to build to really smash atoms?
I want to know where you're at about it. Maybe if you could explain what CERN is to the best of your ability.
Okay.
And your take on what are they doing? And do we need it? And is it dangerous? What's your take on it?
It's not dangerous.
You don't think so?
No, it's not dangerous. I don't think they'll make many black holes that will suck up the Earth, which is one of the claims. Yeah. Whether they discovered the Higgs, it's supposed to be confirmed. There's about 500 people involved, so they're all fighting over who gets the credit. They'll get the Nobel Prize for it. That's $1 million a pop, so I mean, there's a lot of competition there. I don't know. To be fair, I haven't studied that literature recently to see what I think about the so-called, actually,
particle accelerator.
Yeah, I think the original physicist term was not the God particle, but the goddamn particle. And got changed into the God particle. But Peter Higgs hypothesized that there was this elastic field going out through all space and time that lent mass to particles so that matter existed. The idea was, how does mass come into being? When I was first starting in astrophysics, the whole thing was about whether there's a Big Bang, or I call mine the little whimper model because I think it's a combination of matter creation from space-time, but it's not one Big Bang, but multiple energy production systems. So it's a kind of a combination of continuous creation and Big Bang. It was considered very controversial at the time, but actually it sort of made me famous.
You're going to make Stephen Hawking very nervous.
Oh, man. I know. It's so funny because, I mean, now I've got someone corresponding with me that wants me to explain how nothing gets into something. And that is a problem.
Do you think that Stephen Hawking could explain that?
No. No.
How does nothing get into something?
I haven't seen it. I think most of what I see is an exchange of energy and matter from one form to another. And it could be Jean-Paul Sartre, there's nothing anyway, it's all an illusion. But once you stub your toe in the middle of the night, you don't believe Sartre anymore. But anyway, okay, so the idea, and it's kind of romantic because when I was in high school and living in Berkeley, my clock radio, which my mom gave me for Christmas, would go zit every 6 minutes. So I wondered what was going on, but it turns out it was the Bevatron, the proton particle accelerator at Lawrence Berkeley Laboratory. So I started going up there in high school, and what I would do is there was a shuttle bus. And I'd get on the bus, look bored and slightly depressed, and pretend I was an employee, and no one bothered me.
So it sounds like you had a little intelligence operation when you were very young.
I got in trouble for photographing the view, and the Ruskies were doing it, so I mean, I sort of some kind of spy, but I ended up working there for 19 years. But anyway, the idea is, can you figure out the fundamental nature of reality, at least in part, by scattering particles off each other? Now, in a sense, you're using so much energy.
Now, you're talking about CERN or?
Any accelerator.
Okay.
The idea is any accelerator is taking a beam of particles and smashing them on target particles or another beam, like at CERN, to see whether you can create from that energy other particles, and you do. And what is that pattern of nature? What is the symmetries or the quantum numbers that describe these particles? Where did they come from, and what do they represent?
I want you to also articulate your frame of reference on what is the quantum. When you refer to quantum anything, what is it?
Quantum came into being with Planck.
Max Planck?
Max Planck. And there's something called the Rayleigh-Jeans law of black body radiation that was looked at the turn of the last century, before the turn of the century. But the spectrum that they measured from heating up little emitters in a box didn't fit the spectrum that they expected. The energy and the frequency didn't fit. And Planck hypothesized another universal constant than the charge on the electron, the velocity of light, and some of these other things, the mass on the electron and so forth. H bar, or Planck's constant, divided by 2 pi. Now, he could make an equation that fit perfectly with what was observed. So that was the introduction of discreteness. Another paper that was very important was Einstein's 1905 paper on the photoelectric effect. He published 3 papers in 1905. Special relativity, the photoelectric effect, and the explanation of Brownian motion, where little particles in a microscope seem to jiggle by atoms knocking into particles of dust. Now, he actually got the Nobel Prize for the photoelectric effect because relativity remained controversial. But a quantum is a discrete amount of something, and that actually waves can kind of behave as particles at the microcosm, and particles are waves like in the de Broglie equation, that there seems to be some aspect of matter in the collisions in these accelerators that are like discrete billiard balls in some sense, but they also act as waves, and that's called the wave-particle paradox. And I say nature has no paradox. It's our misunderstanding, and it's neither and both. It may be kind of Zen-like, because it depends on what experiment you do on nature as to what you see. So how you do your experiment exposes what you see. So how you build your accelerators, how you interpret that, kind of determines what you think the universe is.
So it's like a filter by which you're going to observe. So
I think everybody has filters.
Sure. So my next question is, there was some consciousness that was discovered that you impact that which you're observing. Do you agree or disagree?
A good friend of mine and a great mentor, John Archibald Wheeler, and my first book really was based on extending his theory of the Planck units and Planck quantities. He said, Monday, Wednesday, and Friday, I believe in the participator effect, and the rest of the week I don't. So he kind of quantized his thinking on it, but we used to discuss that issue a lot. Actually, in order to see anything, light has to scatter off that surface. So by the very nature of seeing, light impacts the surface. Now, it's not as pronounced as the photoelectric effect, where the photons eject electrons that can be picked up as a current flow, but it does change the matter. I cannot see without seeing, so that by the very act of turning on a light or shining a light on something or having the sun light something, changes the reality to some degree, to some quantum degree in the microcosm.
What was the most profound thing to you about the book The Body Electric by Robert O. Becker?
Well, I had known Becker for years before that. And I also had started a group that didn't go very far. I got a group of doctors together.
That's why.
And that's probably what happened. Man, I'll tell you, if you try to steer a herd of physicists, you're not getting too far. But
engineers sometimes.
Well, engineers I can control.
At least they
them.
can make.
No, they make stuff.
Yeah,
they're
stuff,
good for something. Where you herd a bunch of doctors is probably like herding kangaroos.
You gotta love them, right?
Yeah,
you know?
Kangaroos I don't think you can herd. Sheep you can, but kangaroos I don't know. Anyway, I got a group of about 6 doctors and other people interested, and I was going to form a group to look at Saxenberg and Robert Becker's work on the effect of electromagnetic fields on enhancing biological systems and wound healing. Becker had given a lecture, this was before body electric, he had given a lecture in Canada, and I'm sitting there, and this is kind of in the early stages when I knew him, and he was talking about you give cancer to the tail, above the tail of a salamander. Now, it's very hard to give a salamander cancer, but if you don't cut off its tail, it will die. But if you cut off its tail, as the tail regenerates, if that tissue regenerates through cell dedifferentiation and redifferentiation, the cancer goes away. And I'm sitting there thinking, man, if I catch cancer, what do I cut off, my little finger? I mean, you know, this is serious. But I was really struck by it. And so I got interested. I actually gave several talks on some ideas on tissue regeneration, and that kind of led to a whole nother field of looking at electromagnetic effects on biological systems. And like any good physicist, I was completely skeptical. I didn't go to the blackboard and write Maxwell's equations like some people do to say it's not real. What I did is visited people that claimed it was, and one was Bob Beck and the other one was William Van Bice, or Bill Bice, my late husband. I told him that I was skeptical. Well, he had been skeptical.
Now, which one are you talking about, Bill or Bob?
Bill Bice.
Okay.
He had been skeptical, and I met him in '79 through a guy in Canada. He was skeptical, and his wife at that time, who later divorced him, claimed that his equipment was making her nose bleed and stuff like that. And he said, I'm going to prove there are no effects. So he used a series of continuous wave RF frequencies, and he published in referee journals, that showed that there were brainwave changes. And unfortunately, it's easier to find what's detrimental than what's positive. But there's three categories. There's detrimental electromagnetics, there's benign, and there's beneficial.
So electromagnetic, could you define that for the
audience?
audience
I was going to first say an analogy to it's like if you have too little salt or too much salt, you get sick. You need the right amount of sodium chloride and also the sodium-potassium ratio. So what was your question again?
If you could define or at least explain what electromagnetic is for the audience. We hear it, but some people say, oh, that's cell phones. Oh, that's microwave. Oh, what is it?
Well, Heinrich Hertz in 1888 showed that radio waves and light waves had some similarity. And so the electromagnetic spectrum really goes from almost 0 hertz up to X-ray and gamma ray. So you have ELF, extremely low frequency, UF, and then you go up into the RF radio frequency region, then into the infrared, visible, ultraviolet, X-ray, and then gamma ray. So the amount of energy is proportional to the frequency by E equals h bar nu, where nu is the frequency. So all of it's electromagnetic, but it can be pure magnetic or it can be electrostatic as well. The thing is, if the power lines carry a complete sine wave, which they don't always do, Bill and I showed sine waves are benign. It has to be a modulated or a non-sine wave, intermodulated.
You mean to be dangerous?
Yes.
Okay.
Well, to be beneficial, too.
To be beneficial, too.
So what happened was I was giving him the reasons why I didn't believe him, and he zapped me, and man, I'll tell you, I was a believer after that. It was terrible. He managed to sort of undo it, but I'm not sure it didn't have a permanent negative effect. But he definitely was a rascal.
This is the rascal you married?
Yes, I married this rascal after a while, yes.
And spent 20 plus years?
Yes, we became husband and wife, co-inventors, co-patenters, co-paper writers, co-researchers, and...
So you had life and calling together?
Yeah.
How was that?
Great. Absolutely great.
I'll bet that was just like the magic carpet ride.
Oh, it was totally magic carpet. I mean, he died 8 years ago, and I'm still mad at him for going and dying on me. But that was his choice. It's not my choice. Not really mad, but, you know, it was fantastic. It worked. The way I look at it is my first marriage didn't work. My second one did, but he died on me, so I got a 50-50 odds like anybody if I meet somebody else.
But having 20 years is still incredible.
Oh, it was. I mean, we pretty much spent all our whole time. When I used to travel, sometimes he'd get really upset. What would happen is I was supposed to call in. Well, I'm involved with wherever I am in Europe or Asia. And so I'll make some kind of phone call, and two things will happen. One is he'll talk to me, and the other one is I'm busy doing an experiment. Or the third one was, why didn't you call sooner? I was on an airplane. So it was kind of interesting how that turned out. It was very wonderful, and we were very, very productive. And we developed a number of inventions. Oh man, the patenting process is very interesting. You do have to learn how to do it because there's a combination of technology and legality. So every word means something, you know. It's like a legal document. So we bought some books on patents, and we got some good ones, so we learned how to write patents. And we patented in 3 different areas, which I'm working on now and continuing that research. And I reset up our electronics lab. It took me several years to update equipment and get it going again after he died. 3 areas are this. One is a treatment system, a pain reduction system. This is all one invention. Treatment, wound healing, surgical recovery treatment, and current injury. And also treatment for osteoporosis and inflammation. Now, I advanced that by making it a more detailed, complex, interactive wave that depends on the right duty cycles and right waveforms and intensities to match biological neuronal, hemodynamic of the blood, and the piezoelectricity of the bone. It's like normalizing. When a person gets sick, it's sort of like their life battery or the ATP metabolism isn't working right. So this renormalizes the person and allows them to heal. I don't know what extent, but I have seen some really interesting clinical cases that we did. And we get about over a 90% positive effect from the device. We treated people with broken ankles and all kinds of things, surgical recovery.
How do they receive the treatment? In other words, is it light that's flashing at them?
Oh, no,
is
no,
it sound?
no,
is it
no,
what is it?
No. I haven't seen much positive effects from that. Of course, sound can have a lot of influence too. I mean, people listen to rock and roll, which I do, jazz.
Yeah.
It's mostly in the extremely low frequency region. It's from about 3 hertz or cycles per second to about 52 kilohertz, or it's really 4,000, but it goes up to frequencies that are around 52 kilohertz.
You shared something yesterday I want you to explain to the audience. Remember when you were talking about lighting, and some of the new lighting has frequencies that are not beneficial to the human body?
I like the Edison bulbs because they don't have flicker like fluorescence. The compact fluorescence, and actually I was surprised they don't last as long as they say they're going to. It's important to use less power, but our power company said that they're going to increase the kilowatt hour charge because people are saving too much power and they're not getting enough money. That sounds weird.
Okay, but go back to that part about the frequency, because that was very important. Very important.
Any fluorescent light flickers at 60 hertz. Well, that's considered above the perception of human beings. The nystagmus, or the scanning of the eyes, is at 30 hertz. But some people are actually sensitive to that 60 hertz flicker. I don't like it. As long as I can get an Edison bulb, I rebuy an Edison bulb and not a fluorescent. I'll have fluorescents in light fixtures that I turn off and on.
So what's the healthiest bulb you can think of in terms of the cycles per second
or
the frequency?
Well, this is going to play out over time. One thing is the spectrum of an Edison bulb is broader, so it's more like natural light, whereas some of the fluorescents and the diodes are very narrow band, but there are companies trying to fix it so that they will be more broad spectrum and they won't just look white and be a straight beam like they are with the flashlights.
So the frequencies need to be at what to be biologically at least decent?
Oh, it's not that simple.
No?
No, it's a complex intermix of frequencies or spike waves. Like people, they say they don't have heart disease, but they die of a heart attack on the golf course when they're exerting themselves, but they found the power lines were carrying spike waves near there. So as long as it's a sine wave, it's okay. I mean, we took 15 Gauss sine wave and it didn't affect brain waves at all. But if you use square wave or triangle wave or ramp waves and intermix them, then you can do 2 things. You can enhance alpha, which gets a person into meditative, relaxed, and actually overcomes depression, or you can flatten alpha, unfortunately. And we've done experiments in the low frequency area from about 1 to 100 hertz, and also at the upper end, Bill did work with a continuous radio frequency spectrum up to about 1 gigahertz.
What do you think of these phones that are at 1 and 3 gigahertz?
My problem is this: I don't feel like fighting the establishment on this one.
Yeah, no, I understand. But I mean, just the phones that you can pick up and walk around.
Oh, the portable phones. The original portable phones were in the kilohertz region. I had one, and it wasn't a bad frequency. I had got a current walk-around phone, but I stopped using it.
Sure.
And I will use a cell phone if I need to, but I'm not going to sit on it all the time.
Why?
Well, as I say, I'd rather not have my life threatened again.
I hear you.
I prefer not to.
You did have your life threatened, though, once, right?
More than once, but not over this issue.
Right.
What I would have to say is this: they have improved the cell phones so the power output is much less.
Okay.
For the same value. The original ones I couldn't use. I couldn't stand. But it doesn't bother me to use a cell phone for a short time. People live on them. That's their choice. The original ones were flattening alpha. But I definitely am, you know, I don't want to testify. I don't want to deal with it.
I hear you.
Let me tell you the other thing we invented to put that in context. We invented a detector, a very sensitive magnetic field detector with an electrostatic detector that would pick up the Earth and Earth ionosphere natural frequencies. Some of these actually were predicted by Tesla.
Is this like a Schumann resonance?
Not that simple.
Not that thing. Okay, got it.
The Schumann resonance is one of many frequencies. There's a whole bunch of frequencies that are relevant to different aspects of nature, like the D, E, and F layer. And they resonate at different frequencies. And one thing I did with the NASA was we could measure the shuttle exit and re-entry because we could measure the frequency of the resonance of the various ionospheric layers. But sometimes military communications would block out our spectrum. We didn't care to measure what the military was doing. We wanted to measure what we wanted to do, which was nature. Some people got to Congress and wanted to pass a law that you couldn't measure between 1 and 100 hertz. And we had kind of an inside contact with the Library of Congress, and so he phones us up late at night and says Congress is going to pass a law that you can't measure from 0 to 100 hertz, which would exclude one of the main areas of our measurement, which was aimed at us. I mean, as far as I'm concerned, the military stuff was in our way when it was on. And we weren't reporting it to anybody. I mean, we were doing our research and collecting our work in our own lab from frequencies that came into our domain. So I said to him, well, doctors can't measure EEG and EKG, and it wasn't passed. But there are things like that that happen. I mean, as I say, on the cell phone, the power level is so much lower than it was in the beginning. I would use a different frequency, but it's quite complicated how frequency allocation works. You bid on frequencies, like all the different radio stations. They have to bid on frequencies.
Have you ever heard of the spectrum frequency?
No.
Okay.
What's that?
I guess it's a communication that the military uses. It's called spectrum.
Maybe, I don't know.
What do you see happening with the pain machine? What is it called? Does it have a name yet, or is it still in process?
We call it the NPE, non-invasive pain reliever or eliminator. What I see happening is this, and there's a broader picture. I felt for 30 years there's going to be a revolution in medicine, and it has to do with personal responsibility. Hopefully, it will also take place in education. But the revolution in medicine is moving toward gentler, less invasive. I consider that what we have is a complementary medicine. I would say if a person broke their leg, probably would be best to go get it set than to go to a psychic healer and use up their energy, or wrap it with a copper wire and put a current through it. The first order thing is to get it set properly. Then you can do that. But what I see happening is there's the biochemical view, which is taking medication, the mechanical view, surgery and setting bones and so forth, and there's the electromagnetic view of medicine. And I think it's going to be a triad instead of a dyad. And the FDA had said that our application for an IDE device approval for studying our work in a clinical setting under FDA guidelines was the best application they saw, and our patent was the best they saw.
That's tremendous.
We did get into several business situations that did not work, but I still would like to bring this to market because I have seen cases where it's amazing. I mean, relieving pain, people that had been in chronic pain for 12 years, able to go back to work or their lifestyle and function well. Normally, after 2 years of chronic pain, they write patients off, just give them drugs and hope for the best. And
I'm sure you've heard of Royal Rife's machine and many spin-offs of the Royal Rife.
Yes, I have.
Machine, and I want you to share whatever you'd like to about that, because some people will say, well, that sounds like another Rife machine.
It's definitely not.
Why?
Rife is broadband. It's a shotgun approach. And it's also based on encoded frequencies that Raymond Royal Rife and, Steve Ross of the World Research Foundation has a whole bunch of that. But the problem is it's not easy to translate his numbers into regular frequencies. I wouldn't use it, because I want specificity to enhance the biological system. If you broadband frequencies, like from even some of these people with fluorescent or plasma tubes, I wouldn't use it because some are good and some are bad. Some are benign. I'm intrigued by Rife, and I'm intrigued by the Rife microscope, which I have a nice picture of.
Yeah, I do too.
And
it was destroyed,
I think a lot
it?
of his work was destroyed, so I'm not able to evaluate it, except I wouldn't use what they are
currently using today.
There are three different kinds of things on the market. There are devices that probably won't harm you, and they might help. They're not bad. There's some that I definitely would not have near me, and some are, I don't know, you know. For instance, people with permanent magnets, the problem with that is there is a body polarity. A center body of a person is positive and the limbs are negative. That's also true of the salamander and the frog. So you have to keep the right polarity. And if you put permanent magnets of high intensity on yourself for a long time, for a short time it won't probably do much. But I think it's going to have to all be sorted out.
Dean Bonnelly set up a magnetic bed, very different than the Japanese magnetic bed, but there's been like a revolution in the understanding of magnetism. The Department of Fusion is interested in that. And he said that every 100 years we're losing like 5% of our magnetic field physically.
There's a whole bunch of stuff on that, but
what do you think?
Every 10 years they make new charts for navigation. And the Earth's magnetic inclination or angle of field into the Earth and intensity varies all the time. Not greatly, but you do have to draw the magnetic charts. People have claimed, including a geophysicist friend of mine, that the Earth's magnetic field is decreasing in the Bermuda Triangle. I see no evidence from charts that are well done that this is true. However, there's paleontology evidence that there have been look like pole flips in the past. The last one was about 10 or 20,000 years ago. I don't see that happening now. I think what happens is people correctly intuit something's amiss, but they may blame the wrong thing. And as I say, my view is to start from an open-minded skeptic. See, if I was an open-minded, say, it's okay with me for psi to exist. I wasn't even that open-minded with electromagnetic fields. I just sort of dismissed it until I found out it was true. And then I said, let's find the positive effects.
And it's much harder to find positive effects.
Now, as far as people choosing to use a Rife machine or anything, that's a personal choice. And what I had sort of envisioned is a network of advisors. So people had choice. If they got cancer, they would have a choice to have whatever treatment they deemed, whether it was strawberry smoothie diet or whatever. I think they should have choice.
Me too.
It's hard to say what's the answer because the death rate is so great. Now, it's decreased somewhat, but I've known of people that tried alternate therapies and then tried radiation and chemotherapy, and they got very, very sick and died. I'm not an MD, so I can't prescribe. The only thing I can prescribe is think for yourself.
Talk to us about your take on what a fractal is and how relevant or irrelevant the knowledge of fractals is to what you're doing and what's occurring for us.
Okay, fractals are fascinating. There's some fractals we generated. That's my pufferfish fractal. Bill and I, what we did is take universal constants and program them into the Mandelbrot and the Newt Basin and several other programs for fractal production. Got very interesting fractals. I mean, they did look like ferns and so forth. So I found fractals fascinating. I met Mandelbrot. And
yeah, we just lost him a few years ago.
Yeah, he died a few years ago. And I put his obituary in with my fractal file. But it gets into a religion of fractals where everything's fractal.
Well, there's obviously a fascination with it, right?
Yeah, there's fascination with it. I was fascinated with it. To the next step of really formulating a model of reality, I could not see where that would go.
Okay.
And so I think it's kind of into, I tease some of my friends like the ones that are in the Phi religion, which is the golden mean ratio and some of the sacred geometries. It's fine. I just don't see where it goes, but
I don't see where it goes either, by the way. But apparently Some people feel it goes somewhere with respect to cleaning and structuring water. I don't understand it myself.
I don't either. In fact, on the water thing, all kinds of people have made all kinds of claims. But there was one person in Colorado, in Boulder, and they claimed that their water was charged. Well, it was electrical charge on it. I mean, it zapped your tongue. And I took a fluorescent light bulb in it and I turned the light bulb on. I don't know how it got charged, but it actually was charged. But I would be suspicious of most of those claims.
Did you know about Victor Schauberger?
Oh, yes, I do.
Did you accept his research and his life's work?
Well, here's what I see. If somebody makes a foot-long Schauberger thing, you put the water and it spins around in there,
right,
comes out. Now, for it to be cleaned in the earth, it might take miles and miles of passage of that water within the earth to purify it. So a little foot-long thing I don't think is the answer. So I think it's been overextended, and you know, you have to allocate your time.
Yes.
And I'm not interested in spending 2 years studying Schauberger. That doesn't mean other people shouldn't.
Yeah, though there's a lot of people that
And
are.
I mean, when I lived in the country, we had 4 wells, and you just drank that water right out of the ground. And sometimes there's bugs crawling under your nose. But man, it was the most delicious, pure water. And I took and scooped up some of it later when I went back to our wells. And I sent it off for an assay, and under it was some water bugs crawling around, but I got the top surface, and they said it was distilled water.
Wow.
Coming out of the ground.
That's wild.
So that would actually sort of support Schauberger's kind of claim, but I don't think a foot-long PVC with a twist in it is going to do it.
When you call yourself a skeptic, you mean it in a good way.
Yeah, I mean it in a good way. I mean, what I mean is this. If I hear something that I don't know whether it's true or false, like the whole UFO phenomena, I don't say it's true or false. I just shelve it. I just say I don't have any information to make a judgment on it. If I want to, I'll examine it later. I found the difficulty with the UFO thing is that in psi research, you can take it into the laboratory, but I don't think I can capture a UFO and take it into the laboratory, and it wouldn't probably be polite. So I'm not so sure about that. But I don't discount either, and I actually had a secretary that had close encounters, and then I had her regretfully hypnotized. But she said that she saw it at 3 years old in China, but another person wouldn't have seen it. So it's so many different kinds of phenomena mixed together, and abductions and materials and sightings, that it's a huge, huge study to try to sort out. And it may be a bunch of different phenomena that are kind of grouped together. I know one time I made a wonderful sighting. I saw 2 Venuses over the Bay Area from Berkeley. One was slowly floating up, and they were both pinkish. And I went and got my telescope, and one of them was a weather balloon. And the next day they announced a UFO over the Bay Area. Now, I'm not saying everyone is that. I'm just saying that it's a complicated problem. So when I say skeptic, that doesn't mean I don't believe it. I just don't know.
When you discovered non-locality or became aware of non-locality for the first time, and you had that kind of revelation, which altered your consciousness, you weren't expecting that, were you?
You know, actually, the truth is more important than your philosophy.
Right.
So if I'm going to investigate something, and it's very hard to prove a falsehood because it may be that I did the experiment wrong. But if I find out it to be true, I have to be completely open and not care what it says about my philosophy or what I have to change. As I say on the remote viewing, I did spend 3 days talking about it, because what physicists do is they tell their colleagues about their latest discovery, and I knew that wasn't going to go over too well. I didn't think bending spoons in front of the director would get me a raise, you know. I just kind of had enough sense to think that was not a good idea.
But if you were to discover that there was UFOs or there was intelligent life from elsewhere, if you were to know for sure, how would you feel? What would it mean to you?
It would definitely affect my thinking about things.
Really?
Yeah, because, you know, I have friends that are kind of running outside, waiting for the UFOs to take them up to bliss. Others that have had close encounters where they had a miserable time. And it's sort of like anybody. You have to judge what you think of these entities. In other words, you have to decide when you meet a bear in the woods what the bear's interpretation is. More advanced civilizations don't mean more conscious necessarily. My example is how the Europeans destroyed the indigenous people on this continent. I don't necessarily think they're good or bad, but I think I would be not running out and thinking every extraterrestrial entity. I think there's probably life other places in the universe. Whether they get here or not, that's the issue. Or whether they have influence here, that's the issue. But I wouldn't necessarily think you got also always in a good neighborhood with these ETs. And so I guess I would caution that way. I think a lot of things are covered up, so the people that are trying to get the information, I think, are well-minded and they should do what they're doing.
With all your experience as an inventor over the many, many years, both good and bad and traumatic, what would you suggest to inventors from kind of like the learning of your life and the discernment of your life? What would you tell them from the mountain to help them get their works to the world?
Well, first of all, in order to invent something, it has to be new and novel. And by that very nature is something that you're going to have people poo-poo it, be skeptical to it. And so you're ahead of your time automatically. It's like Tesla maybe was 100 years ahead of his time in some of his thinking, or any inventor. So you're going to have opposition to any new idea, and you have to know that. It takes a lot of work. In other words, you have to figure out the sweat equity of just testing something and rebuilding it and doing it over and over. You have to deal with how you're going to protect your intellectual property or give it to the world. And resistance, acceptance, sometimes amazing results that are beneficial. And I think it's a blast. I think it's fun. I think it's great. The two areas that I think are important is medicine and energy production. However, I will make the statement about free energy. I know of a free energy device. It's a sailboat on a windy day on the ocean, but you have to have a sailboat. And you have to realize it's not production from nothing. It's an exchange of energy. But I think we do need to get out of looking at, I did a study for MIT on the wind solar, and actually I thought it would get us further than I think it is. It's better than nothing, but you see, anything like electric car, the trouble is it's running off of fossil fuels. You're just piping it down the power lines. So you have to look, and if you're doing hydrogen production, the same thing. You have to have the energy for electrolysis. It takes a sensible whole energy equality and what I call energy economics to see whether something's viable or not or can be done.
What do you see as being viable and optimal?
I don't have much connection with the nuclear industry now, and in high school I felt there would be wars over oil. Didn't know how bad the water pollution we'd get. But my thought was that maybe we would need reactors. But I think that the waste is not dealt with, and the danger is too great, in my view, to go that way. At least they shouldn't store 40 years of spent fuel rods in the same container as the reactor, because if anything happens, you have a humongous amount of radiation release. And when I took a master's in nuclear engineering, at that time, one of the courses was on studying reactor accidents and their cause. So although most of the reactor accidents we studied, it did kill some people, but it was nothing like Chernobyl or Fukushima or 3 Mile Island. But I think the way to go is with fusion. I have ideas on that. My most quoted paper from '68 was on plasma physics. And it's to gently use the coherent collective states. I don't think the direction it's going in now is the way I would go, but I'm not in charge of the funding. So I think there's all kinds of things. It's too bad that a great deal of the solar energy was cut back. Half of the research was cut back about 20 years ago. And
do you know why, or just?
No, I think Reagan was the one that cut it back.
Do you think he just didn't understand it?
I have no idea. I don't know why he decided that. I had a friend that worked for Reagan, but I don't know why he made that decision. But there was a big, I think it was Boulder, Colorado, there was a big project to try to increase the efficiency, because one thing you have to do is not only have a source that makes enough energy, but to have enough efficiency that you get an economically viable product so people can afford it and can use it.
I would love to see some type of energy produced that is so affordable that it's a non-issue. I would love it.
Well, of course, that's what, when Tesla built the Wardenclyffe Tower in New York, his whole idea was to hook in with the resonances of the Earth ionosphere resonant cavity from his 1905 patents and harness natural energies.
And what happened?
Morgan died and his heirs didn't fund it, and Morgan stopped the funding once Marconi announced he had the radio, because Tesla was saying it was a radio transmitter. It was, but it was also an energy collector and transmitter. Once Marconi stole it from Tesla, then J.P. Morgan stopped funding it, and he didn't want any kind of, quotes, free energy. What I believe it was, and I have actually studied it quite a bit.
Okay.
I was fortunate to know someone that had some of the copies of the correspondence of Tesla between his Colorado Springs lab and the Wardenclyffe project. So he was out in 1899 in Colorado Springs. Someone lent him land to build his lab on. And so those two sets of experiments with the Tesla coils and what he thought he was going to do at Wardenclyffe had something to do with each other. That's a long story of what I think that is. But ostensibly, he did tell Morgan that you couldn't meter this energy. And of course, Morgan wanted to meter anything. I mean, he wants to make money. I mean, that's his motive. So he quit funding Tesla at that point. Now, the reason they took down the tower is because it was still standing prior to World War I, and they didn't want the Germans to target on it, they said. So that was the reason to dismantle it. Now the foundation is still there, and there was a nice program on History 2 on it, where he's got major metal bars going into the ground for about 40 feet below the tower, which is interesting. So there's interesting clues in this whole thing. And when I put all my Tesla stuff together, I and my late husband did some experiments. They were very small scale. And in a sense, in 1905, in Tesla's patent that relates to the Wardenclyffe Tower, he patented the Earth ionosphere cavity as a finite reactive capacitance. So he basically patented the Earth and owned it for 17 years.
Who?
Tesla.
Unbelievable.
So he could have said, hey, that's my real estate. Well, of course he didn't. But that's interesting to draw a patent where the Earth and the ionosphere is part of your circuit. Well, in a sense, when we're doing the detection work, it's a passive detector, so you can't quite do the same thing with it. But it measures these resonant frequencies. One is the Schumann frequency, but it comes and goes, and it varies from about 7.4 to about 7.8. It doesn't stay just at 7.8 or 7.6 where people think it does. Because we measured, we did 30 years of work on that.
It's a long time.
A long time.
Do you think that the future of medicine as we know it, or healing, is all in frequencies?
I don't think so. I don't know whether we're going to have bones doing Star Trek medicine. Probably not, because I think there's always going to be surgical intervention necessary, and
Sure.
I think setting bones. So, you might enhance the rate of wound healing and surgical recovery. That's possible. I see it as complementary, and I also see that things such as antibiotics, if they're not overdone like they have been, or some medications are certainly going to still be of value. I don't see replacing all of that. What I see necessary is a new medicine, partly because it's financially unsustainable the way it is. It's unfortunate. I've seen a malpractice when I was young, but because doctors do get sued now, they have all these extra tests you take, and it's costing money It does support the medical industry, but it's making medicine inaccessible to the average middle class and poorer citizens. And that's unfair. It's unjust. And by having a less invasive medicine, it will, I think, bring down the cost of medicine, all medical practices. It will substitute for some things, such as some pharmaceuticals, but not all pharmaceuticals. So I see it more as complementary, not taking over the field.
In summarizing right now, what is your greatest concern with respect to what you're aware of that's happening on planet Earth? What are your biggest concerns that you're comfortable to share?
Well, one thing, I was about 7, I was having a discussion with my dad about World War II. I thought war was abhorrent and that one of my jobs was to prevent war. As you can see, I've done a hell of a good job. haven't made any inroads on that. My concerns really have to do with how to introduce, and it does have to do with non-locality, the responsibility for thought, psychic phenomena, and consciousness, how we can get a much more compassionate, gentler, kinder view of all of nature and humans. And I grew up in the country, and I felt that wonderful bliss of interconnectedness with all existence. Yes, things are eating each other and so forth, but it seemed harmonious. And I think there's a loss of that experience. And we definitely have, to me, environmental hazards and destruction of huge amount of rainforests. All of that controls worldwide weather. I mean, it does have a big impact. It may have much more impact than any consideration of global warming. Now, global warming, global colding as I call it, because I figured if Al Gore got a Nobel Prize for global warming, maybe I could wait until the winter and get a Nobel Prize for global colding.
I'll give, but you know, the Nobel is not so Nobel anymore, because you can just get it just for showing up to a job, apparently. You don't even have to do anything.
Well, the Peace Prize is different from the other prizes you have to work for.
There you go.
The Peace Prize is a different matter, and you know, some of the people that got it, it may be many people that deserve it. Well,
Muhammad Yunus of the Grameen Bank, who created a bank based on uncollateralized lending.
No, but
he got it. He deserved it.
Oh, no, I'll take it away.
No, you can't take that away.
Oh,
I'm going to, no, you can't take Dr.
I'm writing a letter right now.
No,
I'm going to get an email out.
I'm standing up for Yunus.
To Oslo right now.
I'm standing up for Yunus. I'm going to get it. We're going to get into a fight right now.
Well, the way I look at it, some of the people that did get the Peace Prize deserved it.
He did.
Whether that's true or false, I don't know.
No, I do know.
I don't know, but I don't know much about that. So
that's all right. But I'm telling you, you can just take my word for it. Just,
well, he
just
says
for this
you
show.
Can get an uncollateral. You don't have.
Well, what
that's
he did,
called a credit card.
No. No, what he did is he challenged the entire banking system, and he said people will still pay back microloans without having to have collateral.
Oh, I agree with that.
Okay, and he built a new system based on that.
He's
the one. Yeah.
I think that's true.
It was remarkable. Actually, he built a totally new living organism of banking and totally smashed the false dogma that you have to have collateral to do lending.
But you don't, like a credit card, you don't have...
Yeah, no, I'm not... It wasn't so much. That was just bank loans.
Look at how that's influenced things.
Right, that's a different thing. But
I do understand the microloans. Well, I think some of the people that got the Nobel Peace Prize really did try to do good things.
Absolutely.
So I don't see anybody in the lot that I'd say no to particularly.
How about giving it to a president of the United States before he's done anything?
I know, that's the one you were going to bring up. I had Obama very well in mind. Well,
it's not political. It's just that it was politically given, and that bothers me. That changed it. You know, that changed it.
That's a really that gets into a whole issue.
I know.
My late husband grew up in the South.
Yeah.
And I grew up in the Bay Area in California, and my dad was a Quaker, and he'd hire minorities, blacks mostly, and all the white people would picket. But then most of the people I talked to as a kid were blacks. And I worked for affirmative action for years, and so did Bill.
Yeah, but in this case, my commentary really has nothing to do with...
I think he probably should have waited for the end of his first term and all.
I think so too.
But I'm not gonna judge that.
Sure. We're in enough hot water.
I see some good signs of change and I see some bad.
What are you concerned about, though, right now?
I think the biggest problem right now that's being ignored is the ozone hole, because I think it's like a electromagnetic or electrostatic bubble, and people are ignoring it now, and the causes of it are not what they say.
First of all, do you know what the causes are?
Yes.
Can you share it with us?
It's classified now, but it wasn't classified when I read the papers. They were in Science and Nature. But it's a solid fuel. Well, actually, there's a guy, let's see if I can remember his name, UC Berkeley, the one that prevented the Concorde from flying in the United States. You see, if you have a solid fuel propellant or a jet engine flying in the ionosphere, it actually expels fuel that has nitrogen in it, oxides of nitrogen, NOx, and that catalytically uses up ozone. The ozone layer protects us. So every time you launch a rocket through the ionosphere, it does use up ozone. And I think the fluorocarbons are too heavy to get up there. But those papers were in the open literature.
Yes. So does that mean now, because there's a hole in the ionosphere, that gamma rays are coming into us? Or what does that mean in terms of
sometimes there's gamma rays and X-rays. And yeah, I mean, they used to have ozone alerts. Now, I don't know what the status is right now because I used to kind of keep a daily record of that, but I haven't been for a while. I'd say that was a very serious problem and should be attended to.
Do you think it's recoverable? Do you think we could do anything?
I think if they don't destroy it, I think it will recover in time. I actually think it could be replenished, but that's very dangerous. It would be Tesla technology. I think clean water worldwide is a serious problem, extremely serious water issues. Obviously, whether it's called renewable energy or something, but to get off of fossil fuels. The thing is, oil products are used for so many other things, including making medications, that I don't think it should just be burned up and thrown away. Let's put it this way. After the kerosene lamp, when the incandescent bulb came in, those guys went out of business, but then Rockefeller used that to make oil for car propulsion. So the businesses will change over time. It won't necessarily be, it will have to be an integrated system so that the old system can be eased out without financial collapse. I don't know about the world money supply and the world economics. It's so tied together now. And it wasn't many, many years ago. But there's a dip in one person's market and it's felt worldwide. The Nikkei index has never recovered to, I think it was, it's about a third or less than what it was. And then what does the Dow Jones average really mean? What does that really represent? And what does it represent in terms of people's 401ks and stuff like that? In other words, those are about half the value they were before this current so-called downturn or semi-depression and the bad paper.
What do you think of inventors depending upon venture capital to fund next generation solutions and discoveries or a whole new product line that's going to better life on Earth? Do you think that it should be in the hands of the traditional venture capitalists? Do you think they will see?
I don't know how to get the funding, because the problem is if you have a lot of funds, you want the status quo because those funds exist for that status quo. Any shift in value systems, economic instruments for betterment like inventions, that will shift that. And
control mechanisms will be impacted.
It's very difficult. The funding issue is very difficult, and most of the work I did, I self-funded from my salary and consulting jobs.
Well, that's why I think that, and I've done a lot of thinking over the last 35 years about next generation fundings, that there has to be coherence. There has to be a physics relationship between the money side and the invention side. Because if you don't have coherence, then you have interference into and continuously interfering with inventors and inventions and people that are bringing through discoveries that the world needs.
Oh, I agree with that, and I don't know how to solve it because in the case of J.P. Morgan funding Tesla, if he thought Tesla was going to have electricity free and no meters on it, then he said, I'm stopping funding this. But you see, Tesla's idea was more into the benefit for mankind, which is, he said, I want to free man from drudgery and pain so that he can be free to think and prosper. Those aren't quite his words, but that's what I would say too. But venture capitalists isn't going to see it that way. They want to get their money back multiple times. That's their motive. So how do you mesh what appears to be incompatible motives? And I think we need to invent a solution.
Well, I think that there are many solutions. One is to establish totally different criteria for funding, totally different protocols.
Oh, I agree with that.
Totally different protocols for doing business. That's why I formed my company, to provide a whole systems approach to bringing new knowledge, discoveries, and solutions to the world. Bringing solutions to the world requires a totally different type of approach than just bringing a product to market.
Right.
The disclosure has to be timed very well. The right people have to be brought in and screened. The protocols for doing business, there needs to be a proper amount of filters all the way through so you know who and what you're really dealing with. And there's also a question of what it is you're transacting in. So if you're transacting in paper, you're transacting in Fed dollars, are you transacting in metals, are you transacting in a resource type of sharing arrangement? What kind of contracts you have are vital. This is my work of the last 30 plus years. Who you're dealing with, what you're dealing with, and what's going to unfold always gets distilled at a contract.
Right.
It gets also distilled on the way to the contract.
Right.
So a lot of the hardship can be minimized very quickly up front. I would say this to most inventors around the world. And that in the area of disclosure, in the area of communication, in the area of your contracts, in the area of your jurisdiction of your business, not that there's a safe place to be anymore. We were just talking about there's no necessarily the ultimate safe place to be anymore.
No,
Everything is infiltratable. Everything is attackable.
And
everything is
in
confiscatable.
flux.
Yeah, and in flux. However, there are wiser ways to form a new venture and to establish an organism of sharing, of cooperation, of physics within the company so that information can move, creative can move, new knowledge can move, discoveries can move, and be brought to life in form and matter. So to me, it is about physics. It's all about physics.
Well, I think I met a very wealthy banker, and I said, do you collect money or process it? Because this was supposed to be a possible funding thing, and he says, I collect it. So that's not going to work as an exchange system. If the investor sees it as a process, that's a totally different view, and some do. But I think that incompatibility of the fundamental thinking process of a scientist and an inventor is so different from what is in the business community. And I heard there was a course at Stanford years ago of how to rip off inventors in their MBA program. The point is that it's not synergistic either for the inventor or the investor.
Absolutely.
It has to be just what I say. I mean, it's kind of like the kind of compassion and collective thinking and collective benefit that needs to go into ending war, is to solve this problem, that everybody wins by winning. It's not a competition. It's a cooperation. It's a collective cooperation. Now, how to bring that about, I'll let you handle it. I don't know.
You know, it's a
I don't have your answer for you.
No, well, here's the thing. Here's the thing. We're all going to still exist in a, I mean, even if you're cooperating, you're still in a macrocosm of people that are competing. And therefore playing by different rules, you know, from a different place. So the thing is to establish a magnetic field within the venture of what that is, and to bring the consciousness into the venture from the get-go, from the ground. And that is going to have its way into all contracts. That's going to have its way into business processes. I told you about years ago that NPR had given me an agreement. And the agreement, I don't know, 6, 7 pages or what have you. And I signed the agreement and I crossed out one word. And I don't mind sharing this because I have the document, and if anybody wanted to see it, I could prove it. But it doesn't matter what institution you're dealing with. When it really comes down to it, people, who they are, their consciousness lives in their contracts, in their process of how they do what they do, and the way they do what they do. So when I crossed out this one word, same, and signed the contract but said no on that, I knew exactly what I was saying no to. I was saying no to theft. the license to steal.
Right.
Okay? And I sent it back, and they said I was the second person in their history that have ever done that. And I said, well, that's not acceptable business practice to do that. And if people read the contracts, they know exactly what that meant. Not only is it uncivilized, I mean, forget all that other stuff. It's uncivilized, it's inappropriate, it has nothing to do with honoring people coming together and having an exchange. But inventors need to, no matter how desperate they may feel, no matter how called they may be, they need to learn how to say no to the money and no to contracts that are bad and no to contracts that have sneaky, insidious things like that in them. I said no to one word, and I lost an NPR distribution deal. And who did I send to NPR? My interview with Dr. Muhammad Yunus of the Grameen Bank before he got the Nobel Prize.
Wow. Wow. Well, you know, it's
and I was turned down all over America. So I'm just saying, consciousness to me, you want to talk real practical about consciousness, it lives in business. It lives in business
but
practices.
How we inject it into business? Because here's the situation.
Sure.
My NASA contract and a 4-year Navy contract I had, which was on non-military work, actually mostly in general relativity, when they were funding non-military projects through UC Berkeley, were 1 paragraph.
Awesome.
Now, I've gotten business contracts that are 75 to 100 pages. I read through them. I had 12 guys yelling at me to sign it. And basically, there were 3 paragraphs that would have given everything away for nothing. Now, what are they going to do with it? They actually don't know how to build it. They don't know how to tune it. Why would they be so inclined to want to steal? Why are they so compulsed? That's the only thing they can think of.
I don't know the answer to that, except that it's got to come from greed and people who feel entitled on some level. The contracts are so critical. And by the way, on the way to bringing the venture into total being, agreements are very important. Protocols for doing business are very important. I mean, I have caught things for my clients and for myself along the way, I'll tell you, so early, so fast by the way people do business. They literally give themselves away. You will know quickly whether you're dealing with someone who can cooperate, whether they have integrity, whether they can be trusted, whether they're honorable, whether they will deliver. You can usually tell on the way to and at the contract level.
Yeah, it's true. And even, you know, what I would call nicey-nicey talk. And I remember one time Bill and I met with 2 business guys, of course, near a golf course, which is what you're supposed to do. And man, was that spiel smooth. I mean, they were saying stuff like, they had us totally psyched out, and you know, not a word of it meant a thing. It's amazing.
It is amazing.
I think some of these people may actually lose track of what truth is.
There are people out there that are honorable, and there are people that will be very reluctant to give a commitment unless they're going to deliver that commitment. And there are people that keep their promises, and there are people that are out there. And that's the thing I want to represent to you, is that they're out there. I consider myself one of them. I know a lot of good people around the world. But I'll tell you, I've been through 30 years of having to go through it like you have in a different way. I've had inventors walk, I've even had inventors walk off with stuff that my company brought to life.
Yeah.
And violate licenses. I've had all kinds of things happen. But you know what? At the end of the day, we're at a critical time in human history where now it's time to bring some things, some beautiful things into existence that are very, very needed by the world. And it's a great pleasure and an honor to sit with you and talk with you and to hear about your life and your work and what you've been through. And God, you've been through it. You've really been through it.
Yeah, I have.
I wish for you a great and rapid healing, continuous joy and ease and tremendous grace and a big launch for your new series of devices. And thank you so much.
Thank you so much.
I really,
it's been an extreme pleasure talking to you and talking to your audience. And I wish you all the positive and all of the listeners positive view, positive life, and happiness.
Thank you so much. It's rainmaking time.
It's rainmaking time.